And the answer to this question, as you might have guessed, is that it's any of the above, basically. Because, well, yeah, changes can happen in any order, and that will mean that uh, your variable will change in any possible order. So, if you look at this, the problem is that we must execute three instructions to perform the increment, not just a single instruction. And this calls for us to basically have some way to provide atomicity. Atomicity is basically from the word atom, where you basically, I mean, it used to be thought, well, during a very large period of time that atoms are indivisible, right? In physics, basically, atom was the smallest element that we could recognize. Now we have the quarks and all the other small subparticles of an atom, subatomic particles. But an atom used to signify something that is indivisible, basically, right? So you want atomic operations which either all occur or nothing occurs. So you would want basically these three lines, either all three of them occur or none of them occurs. Because if only single one of them occurs, that means that there can be race conditions as we have seen. So you want something that would look like memory add, where you basically add one in memory, not just not have to copy the data, do the computations, and then copy the data back in memory. So we will cover basically how to design atomic multi-threaded programs over the next lecture or two, and this is basically using many of the synchronization primitives that the operating system provides. We'll cover them both in kernel level and in kernel level and in user space level. Basically, how to protect critical sections, parts of the code which have to be synchronized or basically have to be done in an atomic fashion. So this is a question for you. Where's the critical section in this code? And you might have all guessed it. It's basically line for where you have the addition happening. So now the crux of the problem that we're going to cover is how to provide support for synchronization in the operating system and by the operating system for user level threading. Although this is mostly what we have been talking about, there is another problem that we're going to talk about, which is basically when one thread must wait for another to complete some action before it continues. Sometimes you have dependencies in your code. Part of the code is dependent on another part. And basically, we will talk about two things, basically synchronization primitives and conditional variables. So why are we studying this in an operating system class and not in our programming classes? Well, you should study them in programming classes also if you're doing multi-threaded programming or parallel programming. Most universities would have a parallel programming course separate from traditional programming. But the main reason is that it's history. The first concurrent program, the first multi-threaded program that existed was the kernel, the operating system, and that basically made it very popular that in most operating systems courses you will cover quite a bit about threading. These are some reads that you might want to actually go through. They are non-obligatory. They're just extra information for you. There is this design principle: keep it simple. S, yeah, stupid. Well, KISS is usually used as keep it simple, stupid, right? And do not come up with stupid ideas in in parallel programming. This was a very big thing about code injection that was possible in almost all Windows operating systems since I think '98 or Vista. I cannot remember. It's this happened last year, and you can read more about it. It was a yeah major flaw in the way that they do parallelism in the system. This is again a very excellent read from Tannenbaum, who is like the father or one of the forefathers of operating systems. He's a professor in Vrije University in Amsterdam. He is probably the most influential operating systems person on earth, in the sense that he might not have the highest citation, but almost all leading operating system researchers in the world have been influenced by him. Linux has been influenced by him, and yeah, he's a great guy. And this is basically a sort of a blog post that you can read on what he learned from developing Linux. So next time we will actually cover chapter 28. You have, or you should read chapters 27 the thread API, because this is how you are going to do threading in C. Thank you, and talk to you later.